How was your guys' break?
Good.
It was good.
It was pretty good.
Pretty good?
Except that I barely got sleep.
Yeah, I did not get much sleep either. It's
Because
not
I
good
had
if
this
you
thing
don't
on
have
the
anything
sofa
planned.
bed.
Well, I ended up making a bunch of projects for myself, getting ready for May term, getting ready for that wedding. Who traveled? Who thinks you went the furthest? Anyone go like California? Who went to Florida? How many people went to Florida? Colorado? That's
Yeah,
far. Yeah. Guatemala. Okay, that might be the furthest. How long was your flight to get there?
Well, we stopped in Miami.
Yeah, had a layover there.
We went from there to China.
Yeah. Not terrible, but not fun to be on a plane that long. I don't like the pressure inside of a plane. It makes my head hurt.
I had to eat breakfast and dinner on the same plane trip, and it was so confusing.
Yeah, that is
They
weird.
put us there at like 10 o'clock, though, and then at like 1 o'clock, they're like, here's breakfast.
Well, they're just trying to keep you occupied. So, speaking of airline travel, I feel like I segue into math. So, speaking about airline travel, Data Girl and Misadventure
Oh no.
are trying to collect some information on airlines. So, we are talking about Puerto Rico. Say we're talking about going to Puerto Rico this summer. Now, obviously, if you get on a United flight, they might beat you up. You might get bit by a scorpion or something like that. But so maybe we'll avoid United right now. Like, have you seen the spoof where they strap a guy to the top of the plane? There's this there's this spoof articles. I don't know if you guys ever read like The Onion or those fake news articles.
Yeah.
But there's one where it says airline apologized for strapping man to the roof because they were out like overcrowded or something. And there's like looks like a guy on the roof of an airplane with like ratchet straps just holding him down. So if you missed that, go look up all the fun that happened with United over spring break. But so we're collecting some data about airlines. Now, Misadventure asks the question, how many people flew to Puerto Rico on Tuesday, like of this past week? Data Girl asks, how many people fly to Puerto Rico on Tuesdays? What's the difference between their questions? Andrew?
Misadventure is talking about that Tuesday, and what's the other one's name?
So on Tuesday, you're saying this is talking about a day?
No, that.
Yeah, like a Tuesday, one Tuesday,
Yeah, it's
single
one
day.
Tuesday.
Okay, versus
X amount of Tuesdays.
ooh, some amount of Tuesdays. So like we could say long term or many days. Now, but wait, so if Data Girl collects a bunch of data, because you know she's Data Girl, but so let's say she collects data for 2 months on who goes to Puerto Rico on Tuesdays. Does she then want to like add all those up, all those Tuesdays, and say, oh, this many people flew over the? Okay, so what? Instead of like, you can't just put them all together because that would like make it seem like tons of people fly to Puerto Rico. But your data's over long term. Justin, what would we do instead?
You get the average
Why? Why do we use averages?
to see like the airline. If you get a lot of people and other people can't buy tickets, you could add another airline or plane so you can get more people over there.
How do you think flights are booked right about now during the year compared to 2 months ago?
You buy a ticket.
Like how many people do you think are flying? Do you think more people are flying now or more people flew 2 months ago?
Now,
What's going on right now for like lots of people?
spring break.
Spring break! So, airlines are really crowded right now. I need you guys to keep your attention. So, right now, that flight to Puerto Rico might be booked, totally packed, like extra people. They're going to get kicked off the plane. 2 months ago, when everybody was in work, everybody was in school, nobody was on break, I bet you that flight wasn't overcrowded and overbooked. So, that, and I'd love to get more data on the whole United issue, but there's so many people traveling right now for spring break, that's why all the flights are booked up. Well, 2 months ago it would have been February. That wouldn't have been winter. That's like just the middle of the blah time of the year. Yeah, Casey?
There was like no one. And
Yeah.
then we went down to spring break and it was like, well, it wasn't like crazy like summer, but it was pretty town.
And actually, so we talked back when we did percentages. We talked about airlines overbooking. You don't remember that? We talked about if they book 10% over. And so if you go read up on the United situation, that's the issue. Is that all airlines overbook. If they get to the point that they filled the plane, they overbook the plane, and then they offer to pay people to switch their flight. They were offering, because I brought this up, I might as well tell you some info. They were offering, anyone follow up on this story? They were offering $800, not to not fly, but just to switch your flight. Now, other airlines, I have a couple friends that work for airlines, they were saying we've offered up to $1,300 before. And not just in vouchers, but literally just money to switch flights. They had offered up to $800, nobody was taking it, so then they randomly started choosing people you gotta get off the plane. It was too heavy. You can't fly a plane if it's over a certain point. So, we would, instead of having Data Girl talk about all Tuesdays, like Justin said, we talk about an average. Now, mathematically, when we get fancy, the mathematical word for average is mean. So right here, please, beside me, go ahead and write average. Now, the mean or the average is the first and kind of most popular measure of center. So, measures of center are values that summarize data. Measures of center are values that can summarize a set of data. So if somebody asked me, what are the ages of the students that you teach? Do you think I would say, I teach an 11-year-old, 11-year-old, a 12-year-old, a 12-year-old, a 13, 13, 13, 12, 12, and 11, 12, 12, 13, 13. Do you think I would list them all out? No. What do you think I'd say? 13. I teach 12 and 13-year-olds. Or I teach 13 and 14-year-olds, depending on what time of the year. So, not every student is a 12-year-old. Not every student is a 13-year-old. Those are a measure of center. It's like an average. So we use that to save time. I've told you all year long, I'm trying to make your life easier, trying to make your life better, not trying to make your life harder. We use measures of center to make things simpler, to just talk about stuff. So another measure of center that we may have heard of or may not have heard of as much about is the median. The median, anyone know what the median is if you're driving on the road? If somebody tells you they hit the median, that's a very bad thing. Grace?
Isn't it the middle barrier?
If you are driving on the highway and you look to your left, that cement wall that kind of keeps people safe from crossing over traffic, that is the median. If you care to know. The other side, the outside of the road is called the berm. There's other words for it, but there's the berm and the median. The median is the middle. It's the divider. It splits your road in half. So your median is just the middle value of the data when they're arranged numerically. So now we'll go back and look at how do we do these things. So we've talked about median and we've talked about average. If we use this same data set, notice same data set for average and median, I do not need to order my data to do the average. Their data is already ordered, which is fine. We add them all up, divide by how many there are. So if I wanted to average your guys' ages, add all your ages up, divide by how many people there are in this room. So the average of this data set is 4. The average, the main, there's some below, some above, average, middle, 4. Now the problem with that 4 is it doesn't really tell you that there's some values in the negatives. And it doesn't really tell you that there's some way, it just tells you the average of everything is 4. So if I tell my friends, the average age of the kids I teach are 12, could there be an 8-year-old here? Could there be a 20-year-old here? There could be. That's one issue with average, is because it totally summarizes data, it just tells you the average. So then, what if somebody said, what's the median age of a kid at your school? Well, that would be if I list them all out in order and pick the middle-aged kid. Literally the middle of half the kids are younger than you, half the kids are older than you. So we set them up in order, and I count. How many digits do we have here? How many numbers, values? 7, right? 1, 2, 3, 4, 5, 6, 7. Middle is easy here. I just cut off 3 from the bottom, 3 from the top. I find my middle. This is where it gets hard. I need your attention because this is where people get screwed up. If we had an even data set, so an even amount, please highlight median. We're still doing median. However, here's the problem. If I cut 3 off the bottom and 3 off the top, I now have 2 numbers left in the middle. And this is where people get confused. Your median does not actually have to exist in your data. I do not have any point that is 6.5 in my data. This is in order. I don't have a 6.5. But yet, when I put my data in order and I chop it in half, that halfway point is 6.5. So when we're finding the median with an even set, this is the process to average the middles. Because here we have 2 middle terms. So when I have 2 in the middle, I have to find the average of them. Obviously 6 and 7, that's easy. What's between 6 and 7? 6.5. But if the numbers were further apart, you might mathematically want to add them up and divide by 2.
We used to do this all the time.
Any questions on mean or median so far? Xavier, did I just hear you say mode?
Yeah.
What is mode?
I remember most, but that's all I remember.
That's it. So the other measure of center, because it's not on here. I was trying to remember if it was on here.
Oh yeah, I know what it is.
So throw somewhere on your paper. You might have some space. Off to the side here or something. You should know this. This is a 6th grade standard, but it's okay. We all forget things. Mode, I'd make your own little box or something. Mode is just, remember the MO from mode? It's the most occurring number. Yeah, like whatever happens the most. Up there in the data set that we have, the -5, -1, 3, 6, all that, is there any number that occurs more than the other ones? Abby? The 8 occurs twice. So, in the example above, the 8 is the mode because it occurs more than anything else. There is not always a mode. So if I go up to the example above that, crap, we'll have to use a different one. But let's say that we had this data set. You don't have to write this down. If we had this data set and this 8 didn't exist, just imagine it wasn't there. Or imagine it was like a 12 or something like that. Does any number occur more than any other number? No. Is there a mode?
No.
Nope. There's not always a mode. There's always a median, because it's the middle, and there's always an average. There's not always a mode.
Remember, everybody used to think it was like the biggest number was the
Nope.
most.
Just most occurring. So, if we want to find the mean and median values for interruptions at Yellowstone, which is actually, we won't dive deep into this, but our national parks need some help. They're being defunded, and yeah, there's a lot going on right now. You should go visit the parks while you have the chance. But we've got some data listed to us, but not listed out. What does this dot mean? 5.5, right? It's between the 5, and if I look at the range up to 10, I know that each of those tick marks is worth 1. So my first data point is 5.5. Let's go ahead and start listing these. What's my next data point that I have? 6. And this is minutes between eruptions. So like if you're waiting there and you want to see multiple eruptions. What's my next data point? 7. How many of those do I have? 2 of them. Then I have an 8, an 8.5, a 10, and a 10. Now, if I just listed my numbers, make your life easy. Do your median first. Because you've got your numbers in order. Let's count how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8. Right. So what's half of 8? 4, right? So I go to the fourth. 1, 2, 3, 4. Yay! 1, 2, 3. Crap. I have 2 medians. Well, not really, because I can only have 1. So what do I do when I have 2?
Divide.
Well, we have to do something before we divide. Add them up, then divide. So add these together and divide by 2, and you just get 7.5. That will be your median value.
Only add 7 and the 8 up.
So 7 plus 8 would be 15. Divided by 2 gets you the 7.5.
Oh, I thought you added
What's the
every
middle of
single thing
7
No.
up.
So you're thinking of the total average. We were finding median. So give me your eyes for a second. This is a confusing process. When finding the median, we sometimes have to use the average process because we had to figure out the median of these 2 values because that's the median of the whole set. So to do that, we average. That is not our average for the data. It's just our average for these 2. So then if I want to average for all of the data, we got to add up everything. So let's find our sum. So help me out. You guys got calculators. Pair up what you can. The 10s pair up nice. The 7s and 8 pair up nice. 15, 30, 50. If I beat you guys, 56, 61, 62. That was very quick. I probably made a mistake, but I think it might be 62. It is? Can we verify it? Somebody else? Another calculator? I need 2. I trust Shane, but I need 2. Somebody else add this up? Sweet. 62 for our sum. Then we have to divide that by what? 8. Because there are 8 digits. That's our quantity, how many values we had. So it's your sum divided by your quantity.
7.5.
Well, it's like 7.7.
Okay, somebody back it up. It's around 7.
I think
7.75. It is good when my mean and median are close together. That means my data set is pretty well centered. If my mean and my median are far away from each other, it means my data is not very centered. It's probably very spread out. So the measures of center also, when we compare them, tell us, what about mode? What's the mode here, Abby?
Wouldn't it be 10? Wait, no, it would be 10 and 7.
Ooh, and then it can't be either. So since the 10 and the 7 both occur twice, there's no mode.
Oh, yeah, because isn't there only like one mode?
There can only be one mode. If the 10 and the 7 both occur twice, nothing occurs more than anybody else, and there's no mode.
My teacher probably.
So if you were planning a trip to Yellowstone and you wanted to approximate how long you might have to wait to see an eruption, Hayden, what would you say? You might have to wait 7 to 8 minutes between eruptions.
7.5.
So there's 7 to 8 minutes between
7 to 8 minutes.
eruptions. And that is how we use measures of center. Like when they say you'll have to wait approximately 15 minutes for your oil change, that doesn't mean it's actually 15. It might be quicker, might be longer. That's a measure of center.
Oh, it's like how long the flight might take. Like some people say, like it's between.
Yeah. A lot of times, if you watch the news, you'll hear people talk about median family income, which means if you look at a area, let's say Ohio, if they look at median family income for Ohio, you take everybody's family income, put them in order, chop off the bottom half that make the least, like the lower half, chop off the half at the top, and look right at the middle. they'll say the middle amount made in Ohio is whatever. But that's, if you ever hear them like on the news talking about median family income, it's the middle, literally the middle value. So now we're collecting data, and you would use trig to do this, unless you had some lasers or something. We collect data on how high the eruptions go. We want to like set our little brother on there and shoot him up in the air. So we have this data set. Are we in order?
No.
Nah. So since we're not in order yet, choose what you want to do. You could go ahead and do average because you don't need them in order. So if we want to do the average or the mean, try to get used to referring to average as mean just to get comfortable with it. We're again going to do the sum over the quantity. So in your calculator, we're just going to do 15 plus 30 plus, just do all that sum. Somebody verify for me, please. Really, everybody. That would be great if you were working it and verifying. What do we get?
189.
Verification. Yeah, there it is. So our sum here, 189 is what they got. How many data points did we have here? 189 divided by 9 comes out to be 21. Oh, sorry, that's not minutes, that's feet now. Did you say dead mean?
Dead mean.
Good. I've been waiting for that to die. I've been waiting for a class of kids, which I knew would take years, or I could say 21 and they wouldn't snicker. Like, that's when you know something's really dead, right? Like, it's been old enough. So, on average, 21 feet. So if you're there and the eruption's like 8 feet tall, you're like, this is lame. That's a low eruption. If you're there and the eruption's like 40 feet tall, you're like, this is sweet, it's the coolest. Like, none of them went that tall. I want to go to Yellowstone. I've never been to Yellowstone. I would love to go see the geysers. But on average, you could expect 21 feet. On your own, find the median. On your own, find the median. Try not to look up here. On your own, find the median. This process is slightly harder. Some people like to cross out their numbers as they use them and they are listing them in order. I like to just count and make sure that I have all of them.
Oh, I usually just put a dot on top of it.
Yeah, something to know that you used it already. Oh, yeah.
Oh, last year what we did is we would like take our test scores.
Notice how I don't use either of those. And at the end of the year, when I give you my physical on a piece of paper, give me feedback, that goes to nobody but me. But through that feedback is why I don't use digits or STM anymore. So when I give you that, please be honest. You're not going to hurt my feelings. Tell me what you liked, what you didn't like, so I can become a better teacher. That's like a month from now. But at the end of the year, I like to survey my students, figure out what I did well and what I can do better at. Casey, how many values do we have here in our data set? 9. So what will be the middle data point? So if we can't figure it out, just go through and make it happen. Take 1 off the top. 1 off the bottom, 1 off the top. 1 off the bottom, 1 off the top. And I would cross these out, but I just don't want to cross them out. 1 off the bottom, 1 off the top. 1 off the bottom, 1 off the top. I've taken 4 off the bottom and 4 off the top, and I now only have 1 value left. So that means that this 22 is our median. There's no other work to be done because this data set had an odd amount of data.
It's not 21, it's 22.
So an odd amount of data is a good thing. So our median here is 22. Our average is 21. They're very close. This is good. My data is well centered. Yep.
Yay.
So for the mean, the other thing you would add up 22 and 23 and then divide by 9.
Only if we had an even data set.
Okay.
So say I had another data point out here, like 32 feet or something. Then once I have an even data set, I have to do that work with the two numbers.
Got it.
So, any other questions about measure of center? Let me talk about where the data is centered. Mean, median, or mode. By the way, is there a mode up here? Nope. Again, no mode. No number occurred multiple times. They all occurred once. They all tied. Any other questions? Measure the center. Measures of variability. I need you to hear me when I say sound complicated. I think whoever did this first wanted to impress his friends. And he was like, I'm going to use as big of words as possible. Really, though, you just have to understand what they mean. So we end up abbreviating to IQR. We'll get there. But when we start talking about variability, so let's go back to the whole age of the student. So I tell somebody, I teach 12-year-olds. Not all of you are 12. So they know that when I say I teach 12-year-olds, not all of you are 12. So then my friend says, okay, well, what is the range of ages that you teach? What do you think the youngest person in Phoenix probably is? Beginning of sense, like 11, right? Probably, sometimes we have 11-year-olds, beginning of the 7th grade year. What do you think the oldest person in Phoenix is? Student. 14, probably. I don't think we normally have any 15-year-olds. So if my youngest is 11 and the oldest is 14, what's the range of ages?
11 to 14.
How many years is that? 3 years. 14 minus 11. There's a 3-year age range between young 7th graders and old 8th graders. So if I told my friends, oh, I teach 12-year-olds, but there's a range of 3 years, they'd know it might be a little under 12, might be a little over 12, but there's only a difference of 3 between the bottom and the top. So range is literally just biggest minus smallest. So range is fairly easy. Max minus min. So make little notes off to the side if you want. Max minus min. Hey guys, you really shouldn't leave class right now because you're gonna hate that you missed this. So Andrew, you should really come back in here until I get done teaching this section. You're just like, it's just not a good idea to miss this. How many quarts are in a gallon? Because quart means 4. Quad means 4. This is why I wish that we would not mix. The problem with like mixing quarts and gallons and milliliters and liters, and we're using 2 different measurement systems. So this is why it's hard for you guys. But our base gallon, they broke up into fourths and they called them quarts. So all that quart means, I'd love for you to write this if you would please,
It's like 4 squares.
means fourths. Or 4.
I definitely reminds me of 4 square.
Or you can just highlight, but your brain is better when you write it. Here's the really crucial part. There's the same number of data values in each part. So what we're going to do is we're going to take all of our data and break it into 4 pieces. But I want the same amount of data in each piece. So I'm going to make little checkpoints that are the division between the sections. Give me your eyes for just a minute. Don't write anything because this is confusing. Give me just your eyes for a second. They now split their data into 1 section, 2 sections, 3 sections, and 4 sections. Each of their sections only have 1 number. Now this is confusing, so hold on. This is confusing. How many data points do I actually have? There's actually 7, right? If I count 1, 2, 3, 4, 5, I have 7 data points. The problem is 7 doesn't divide by 4. Right? We know that. 7 doesn't divide nicely by 4. So to make 4 sections of data, I have to figure out, well, okay, 7 divided by 4 would be 1 and whatever. Some decimal value. It would be like 3/4 or something. So then I realized the max values I can have in each section is 1. I can only have one data point in each section. So we introduce what we call quartiles. The quartile is the number that splits things apart. So the first quartile that we care about is actually the median. So please highlight, circle, star, something. This second quartile, which it's the first one we think about, but it is actually named the second quartile, it's actually just the median. So the first thing we do, so this, we're going to do that first. Split your data in half. So if this was my data, I'd find that 7 is the dead middle. Because it is the middle, it's now gone. Like, quote unquote, I can't use it again, so I'm going to put it like in a little box. I cannot use it again. It's been used as the median. It is quartile 2. It is a data point. I've used it. Are my upper and lower halves equal to each other with amount of numbers?
Yes.
We've got 3 numbers and 3 numbers. So now my bottom half, I do this again. But when I go to find the median again, I'm only working with 3 numbers. What's the middle of 3? Well, the second one. So then this becomes another median, which is my first quartile. And we call it first quartile because it's the first division, like first split for the 4 pieces, quartiles, 4 pieces. And we do that again with the upper data, and we find my third quartile. All of those quartiles are just medians, but we find the median multiple times. So we find the median to split our data into 2 different groups, and we find the median for the low group and the median for the high group. Then the last thing you have to learn today is the interquartile range, which we almost always abbreviate because we are efficient and we don't want to write everything out. So IQR is how we talk about interquartile range. It's just the distance between them. So my first quartile was -1. My third quartile was 8. That distance between my lower quartile and my upper quartile is 9. Any questions here? By the way, we often rename third quartile and first quartile just using Q sub. And when we say sub, it's using the little. So we just say Q3 minus Q1. That's how you could write that really quickly. Instead of writing out the word quartile, because that's annoying, just write Q3, Q1. Now, what you maybe haven't realized, you guys ever seen box and whisker plots before?
Yeah, we did it last.
A box and whisker plot has all of this in it. Everything I just taught you is communicated by a box and whisker plot. So, Data Girl and Misadventure end up in some hot springs in, doesn't tell you. There's a bunch of hot springs in Iceland.
Dubai.
Oh, yep. Oh yeah, Yellowstone. That's why the geysers happen, because the pressure and the hot water and the lava and all this stuff. So, this is already broken up into quartiles for you. If this is all of your data, then this section has 25%. This section has 25%. This section has 25%. And this section has 25% of my data. Justin?
So do we chop the 170 first?
So the edge, like the edges, are what you want to look at. And this box is really like multiple boxes. So we look at, so let me explain to you why we do this, why we do box and whisker plots. If you're looking at data, and especially if you set up, this data is close to each other, but if you want to only look at the main chunk of data, a lot of times we chop off a bottom section, we chop off a top section. This middle box is the main 50% of data. 25%, 25%. So the first thing that we do, like Justin said, is look at the 170. This is our median, which also means that it is our quartile 2. It is the median. it is 170. But if I look at the edges of my box, where's the lower half cut mark and the upper half cut mark? Well, I've got this edge here, and I've got this edge here. So this will give me quartile 1, and this will give me quartile 3. What do you think? Quartile 1's probably like 155?
Yeah.
Yeah? And quartile 3, it's real close to 190. 180, what do you guys want to say?
Wait, then how come?
188, it's probably closer to 188. How come
What
what?
about the dot at the end?
We don't care about him.
Oh yeah.
Now, if, no, not so. This dot is the absolute lowest point. Remember, the quartiles are those cut points in the middle of data sets. So, if we just wanted to find the range, because now we can actually get to answering our questions. And it asks me, find the range. That has nothing to do with the quartiles. When I look at just range, it's everything. Hayden? Now I use my uppermost point and my lowermost point. So this is my max, and it's, I don't know, 202.
Yeah.
Sure, close enough. This is my minimum, and 143, 144. 144, I'll go with. Any questions on how I'm breaking out my box and whisker, what the pieces and parts are? Yeah.
I thought you used Q1 and Q3.
For interquartile range. So we're answering two different questions. The first one they ask us is kind of easy. It's just range. The next one is interquartile range, which is where it gets a bit more complicated. So for just the range, it's everything. Biggest number, smallest number, oldest student, youngest student, whatever situation you want to think about. So here we do 202. I don't want to still be in a highlighter. So for just range, it's 202 minus 144, and we get 58.
That's the range?
That's the total range. Between the lowest value and the highest value, there's a difference of 58. But now, if we forget about the lowest chunk and the highest chunk, and we only look at the middle, we only look at the box, then they ask us the interquartile range, and that's what goes from here to here. That's the interquartile range. So we already identified Q3 and Q1. So just take our quartile 3.
Add all of them together?
No, we subtract because it's
Oh.
range. Our range means difference.
Oh yeah.
So we do 188 minus 155. And in the middle of my data set, what's the range there, Xavier? Interquartile range.
I screwed up. Okay,
So 88 minus 55 should give me a 33. So when I look at my data set all together, I've got a difference of 58 from low to high. When I look at only the middle chunk, my difference is a lot smaller. It's only 33. So we could say the most dramatic differences. Anthony, what's the coldest this hot spring will ever be?
140.
And the hottest it'll ever be?
200.
At max changes. But most of the time, where's the hot spring temperatures?
170.
Well, between 155 and 188. Like, that's the most of the time. The average of all this, well, we don't know the average because we don't know how many data points. So when you're just given the box plot, or the box and whisker, you can't find average. You can't find mode. You can identify the median, and you can talk about the variability, but you can't find average.
It's more of like an educated guess.
Yeah, so we could say they hang out on average based on a range. We could say the average is between here, but we can't say a specific number for the average. And that's how we would talk about the variability. So most dramatic changes are about 60 degrees. Normally, they're changing by about 30 degrees. And I might, depending on what the next thing is. So go ahead and just, so we can start on this, list this out in order. And if you want to take on a challenge, then between now and when we see each other tomorrow, try to go ahead and figure out the IQR for this guy. But aside from that, we're out of time, so please get this clipped in your binder. Make sure you don't lose it. You got to finish it tomorrow. Give your homework a shot if you want, if you feel comfortable, but we'll finish up this lesson tomorrow. So I'll make the due date like Wednesday at earliest, probably. Thanks, you guys. Have a wonderful day. Quit breaking my stuff.